Alright, we're doing the Calculus AB practice test. I'm going to do the multiple choice parts here. I'm just going to give you guys the FRQs as the scoring guides, but I'll make videos for these parts just so you guys can see the problem solving going into each section. So we're doing Calculus AB, Section 1, Part A. This is non-calculator, so don't get out the calculators yet. We'll get to that eventually. Question number 1, always easy, always a favorite. It's a simple integration. Notice that we do have an embedded function here. Whenever you have a function within a function, or layered functions, it's good to think of u substitution just to keep it simple. So if we say u equals 3x, then du would be 3dx. And we know that the integral of the cosine of u du is just sine of u. The antiderivative of cosine is sine. And then we got plus c. So that helps us in undoing that chain rule action there. Let's see what happens then with these pieces we have here. We know that we have this 3 for the du, but it's not in this one. So we need a 3 inside there, and I'll balance it with a 1/3 on the outside. Now I have my du and my cosine of u. So this is really 1/3 the constant on the outside times cosine u du, which winds up being 1/3 sine of u. Okay, once I have that covered, I can translate it, plus c, don't forget the constant like always. Once I have that there, I can substitute the u back in, 1/3 sine of 3x plus c. That means the answer would have been c. Let's look at number 2. Alright, we have a limit here as x approaches 0. A couple of things to notice. If I were to plug in 0, I know that I would get 0 plus 0 on the top and 0 plus 0 on the bottom. That doesn't work, because whenever I have 0 over 0, that means there's a hole. We need to do some algebra. So I look at this and I see that maybe I can factor a little bit. Let's see what I could factor out of the top and the bottom. Well, I see that x cubed can come out of every single one of these terms. So I'm going to start with that. So limit as x approaches 0. I'm going to have x cubed, and then on the top I'll have something left over, and x cubed on the bottom, and then some factors left over. So if I factor out x cubed, up top I would have 2x to the third plus 6, and then on the bottom I would have 4x squared plus 3. Now these two x cubes will reduce, they'll simplify. X cubed over x cubed, this simplifies to just 1 over 1. And then if I were to plug in 0 to the top and bottom now, I would have 0 plus 6 over 0 plus 3. So that equals 2 if I simplify all those pieces together. Answer's D, 2. Number 3 here, the function f is defined above. Notice it's a piecewise function. That means we gotta see what's happening here on either side. For what value k, if any, is f continuous? Alright, continuous means that the left, the middle, and the right are all equal to each other. That coming from this side, the point that you hit in the middle, and coming from the right, all hits at the same place. Right here. Well, let's see what's going to happen with these functions. This top one represents the left and the middle, both at the same time. And then here, this one is the right side. Right, so the left side is x squared minus 3x plus 9. And the right side, this has to equal kx plus 1. And you're probably thinking, wow, I can't really solve that. Except we know what x is when all this is happening. That split is at x equals 2. So I'm going to replace all these x's with 2's. It means I'd have 2 squared minus 3 times 2 plus 9 equals k times 2 plus 1. So this is 4 minus 6 plus 9 equals 2k plus 1. Got negative 2 plus 9 is really 7 equals 2k plus 1. Keep simplifying. 6 equals 2k. If I subtract 1 from both sides, k equals 3. The answer is C. So yes, it is continuous, because if we were to plug in 3, in other words, the limit as x approaches 2 from the left is going to be, let's see, it's whatever I plug into the top one. If I plugged in 2 squared minus 3 times 2 plus 9, that was 7. So that equals 7. And f of 2, if I plug in 2, equals 7. And then the limit as x approaches 2 from the right is also equal to 7. If I plug it into these pieces up here. That's how I would have checked my work if I really needed to. If f equals this and f prime equals this. In other words, it's just saying take the derivative, wow, chain rule, inside function, outside function. So whenever we have an inside and an outside, it's going to be the derivative of the outside of the inside times the derivative of the inside. That's not really the cleanest way to write it. In fact, let's just clear the page. So that's not really the proper way to write that. But we should know what this is. It's just chain rule. Chain rule. That means that I'm going to do derivative of the outside. I have cosine of 4x cubed. Ooh, we have multiple chain rule going on here. We got 3 layers, because here's the most outside layer. Let's start with that in blue, that 3. Then the next inside layer, the middle layer, is going to be the cosine. Then the third layer, we'll do in purple, is the 4x. So let's start with the blue. That means we're going to have 3 times something squared times the derivative of that. So we're going to first rewrite this as cosine 4x. Now we've got to take the derivative of that. Well, the derivative of cosine of 4x, that's a chain rule in itself, because we've got to take the derivative of the cosine piece. Let's do that in red, like we were saying. So the derivative of cosine is sine, and we're going to do sine of 4x, times the derivative of the 4x on the inside there, which is 4. Because we got a lot of stuff going on here. I do notice that this 3 and 4 are just constants, so it's going to be simplified together. So that's 12. Then we have cosine squared 4x sine 4x. Cosine squared 4x sine 4x. But you know what? I'm thinking that I'm missing something, because when I took the derivative of cosine to sine, I need a negative. So this should have a negative up front. That would mean B is our answer. Got to be careful with those negatives, because the derivative of cosine is negative sine. Next, number 5, the function f is given by, here, it has a relative minimum at x equals. Well, in order to figure this out, we first have to take the derivative, because the derivative tells us slope, and we can use slope to interpret highs and lows, increasing and decreasing. So, the derivative, this is a simple polynomial, so we're going to use power rule. It's going to have 6x squared minus 6x minus 12. I notice that I can start factoring this a little bit. I'm going to factor out a 6 from each of those. 6 times x squared minus 1 x minus 2. I think that I can actually factor that, but let's double check. If I were to multiply to negative 2 and add up to negative 1, that would be negative 2 and positive 1. So these are my factors. If I set this equal to 0, I can determine where I might have a relative min or max. Well, that 6 doesn't really matter. If I divide both sides by 6, this is still 0. but I can set x equal to 2 or x equal to negative 1. Well, we can do a sign chart here. Let's see what happens. If x equals negative 1, then we've got to pick something in between. And then 2 and something after 2. We also have to pick something before negative 1 as well. So actually, you know what? Let's redo that. Let's make it a little cleaner. Let's do some straight up and down lines instead of those diagonals. I like to do gray for drawing these lines, so it doesn't stand out too much. So for the x values we're looking at, we have negative 1 and 2. And now let's go ahead and pick numbers around it. So before negative 1, let's see what's going on at negative 2, what's happening at maybe 0 in between, and then maybe 3 after. So if I'm looking at f prime, well, we know that it's 0 at negative 1 and 2. So that's flat. It's neither increasing nor decreasing. And that means that at negative 2, if I were to plug that in here, it would be negative 2 minus 2, that's a negative. Negative 2 plus 1, that's a negative. Negative times a negative is actually positive. And then here in the middle, between them, this is going to be negative. And here at the end, it's going to be positive again. So that means my graph is going to go up, down, then up. So I'll have a max at negative 1 and a min at 2. And this is asking for where is the relative minimum at? It's at 2. C is the answer. Again. Let f be the function given by f of x equals this big product chain kind of thing. Which of the following is equated for the line tangent to the graph of f at the point where x equals 1. Well, let's simplify some stuff here. I see that this is a clear product rule where I have like a u and a v, or an a and a b, or f and g of x, however you want to say it. But I have two parts here that are multiplied by each other. And I know that u equals 2 times 2x minus 1, to the 5th power. And that v equals x plus 1. To simplify my life a little bit, I'm also going to find the u prime and the v prime right now. Just because I know I'm going to use those in the product rule. Because f prime of x, in this case, the derivative, is going to be u, the derivative of u times v, plus the derivative of v times u. And so u prime, this is a chain rule, but not too bad of one. It's going to be 5 times something to the 4th times the derivative of that inside. So we have 2x minus 1, and its derivative is 2. And then here we have v prime is just 1. Well, that was rather easy. Derivative of x plus 1 is just 1. Right, so u prime v, that's going to be 5 and 2 really makes 10. So this is 10 times 2x minus 1 to the 4th. So we have 10 times 2x minus 1 to the 4th times v, which is x plus 1. And then what else do we have here? Plus v prime u. Well, v prime is just 1. And u is 2x minus 1 to the 5th. So that is our derivative. It's talking about tangent line. We need to look at the tangent line at 1, at x equals 1. So we need the derivative value at f prime 1, because this is the slope. So f prime 1 equals 10 times 2 times 1 minus 1 to the 4th times 1 plus 1. Plus, and over here we have 2 times 1 minus 1, all that grouped together to the 5th. Alright, then that means we're going to have here, inside each of these, 2 times 1 minus 1 is really just 1. And 1 to the 4th power is 1, 1 to the 5th power is 1. So we got a 1 at here. This is 10 times 1 times 1 plus 1, which is 2, plus, and then over here we have a 1. So we got 20 plus 1. So the slope is going to be 21. Automatically I'm going to eliminate C, D, and E because it's got to be one of these. So then the thing that we need to look at is how do we find this y-intercept on the end? Well, remember that for tangent lines, it's very easy to use point-slope form to find equation of any linear function, which a tangent line is. And here's the pieces that we have. We don't know y1. So we got to figure that out. How do we figure out the y value? Well, we have to plug in 1 into the function, because really this is like y minus f of 1 equals f prime of 1 times x minus 1. Here's the x value, the slope, and the y value. So let's figure out what f of 1 is. F of 1 is going to be 2x, or 2 times 1, pardon me, minus 1 to the 5th times, what's the second part of the product? It was x plus 1. So that's 1 plus 1. Well, 2 times 1 minus 1 is 1. 1 to the 5th is 1. So that's a lot of 1s. It's 1 times 2. So f of 1 equals 2. So that means that this is going to be y minus 2 equals 21 times x minus 1. Well, I can already see that this is going to be 21x minus 21 and y minus 2. Add 2 to both sides. It's not going to be that one. It's going to be the one that has a 19 in it. So it's going to be y equals 21x minus 19, which in our case would have been B. So that's pretty tricky because 2 equals f of 1. It does not equal the y-intercept that we were really looking for, which was negative 19. Number 7. Ooh, got some interesting things going on here. Immediately before I start getting too complex, my brain is thinking I have the integral and it's in some form of e to the u du, something like that. Because if there's an e in there, it's probably going to have e to the u du. Well, if I were looking at that, I'm thinking that u equals x to the 1/2 power, or the square root of x. Then the derivative of u, or u prime, oh, by the way, the derivative of e to the u du, this is e to the u. So as I'm looking at this, or e to the u plus c, pardon me, what I'm looking for is what's u and du. I need to identify u and make sure that my du is there. Well, du, the derivative of x to 1/2, is going to be 1/2 x to the negative 1/2, which is really 1 over 2 times the square root of x. Oh, dx, by the way. dx. So I look over here, and I have a square root of x in the bottom. Check. And I have the dx. Check. What I don't have is this 2, so I need that 2 in there. So I'm going to do some balancing. If I divide by 2 on the inside, but multiply by 2 on the outside, that's really just multiplying by 1. And those are constants, so it doesn't matter if I multiply on the inside or outside. So this is really equal to 2 times the integral of e to the u du. But I know what the integral of e to the u du is. It's e to the u plus c. So this is 2 times e to the u plus c, which is really going to be 2 times e to the square root of x plus c, which would be A. Dun, 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 dun. Number 8. The function f is continuous on the closed interval 0 to 6 and has given values in table below. Trapezoidal approximation with 3 sub-intervals of equal length is 52. What is the value of k? Alright, so we got a trapezoidal rule. What that means is that I have one trapezoid plus another trapezoid plus another trapezoid. And these heights here, these are the function f of x. And these intervals, this is 0 2, 4, and 6. And these intervals are all going to be too long. So it's 2, 2, and 2. And we know that altogether, if I add up these three areas, that equals 52. The sum of these three areas. Well, let's figure out what the three areas are. This first one I can actually do because this is 8 high. That goes up to 8. So this is x down here, and these are f of x up here. So that's 8, and this last one is 12. So the area of this trapezoid is 1/2, or actually it's the average base. The average of 8 and 12 is 10 times the distance here, so 2. That'd be 20 for that box. And for this one, we don't know what 2 is. It's really k. So this one's going to be k plus 8 times 2, but also divided by 2, so that's really just 1. And over here on this side, we have k plus whatever the original one here is, which is 4. It would be k, and we got a 4. Then we divide that by 2, and then multiply by 2. Where am I coming up with that area of a trapezoid? The area of a trapezoid, of each one, is 1/2 the bases, base 1 plus base 2, times the height. And in this case, it's kind of on its side. So our bases are vertical and our height is horizontal. So our height is going to be 2 in each of these. And we have this 1/2. So we just have to add the two bases together. So this 1/2 is really, we're simplifying with that 2. So it's just base 1 plus base 2 for each of these boxes. So I know that 4 plus k, that this area, plus the middle area, which is k plus 8, plus the third area, which is 20, is going to be equal to 52. All right, it's just an equation. I just need to simplify here. That means I have 8 plus 4 plus 20, that's 32. And I have 2k, so 32 plus 2k equals 52. If I subtract 32 on either side, and I have 2k equals 20. If I divide by 2, k equals 10. It's not too bad. It's a little bit long, but hey, this is calculus. We should be used to the challenge. Next problem's coming in 3, 2, 1. Where'd it go? Oh, there it is. A particle moves along the x-axis at any time t equals 0. Velocity is here, given by this function. If the particle is at position x equals 7, when time t equals 1. So in other words, let's say position is really x of t. What it's saying is if you plug in 1, so x of 1 equals 7. What's the position of the particle at time t equals 2? It's asking what does x of 2 equal? There's a lot of things that we could do here, but it's probably easiest to just find the position function and then plug in 2. There's a couple of different ways we can do it, but let's go ahead and try that. So I know that position is the antiderivative of velocity. Well, v of t dt, pardon me. So that's the antiderivative of 4 minus 6t squared dt. Which if I take the antiderivative of 4, that's 4t. The antiderivative of 6t squared is going to be 6t cubed over 3. But that 6 and 3 are going to simplify, so we'll just have 4t minus 2t cubed plus c, of course. And that's our x of t, you could say. But we need to figure out what this c is, because we need to plug in 2 and figure that out. But I know if I plug in 1, x of 1 equals 7. So that means plug in 1 in for the t. So it's going to be 4 times 1 minus 2 times 1 cubed, and the 1 is a cubed, and then plus c. Well, 4 times 1 is 4. 2 times 1 cubed is just 2. We got plus c, and all that's going to be equal to 7. Simplify this for 2. We got 7 equals 2 plus c. 5 equals c. So really, x of t is equal to this function here, which is 4t minus 2t cubed plus that constant, which is 5. So x of 2 is going to be 4 times 2 minus 2 times 2 cubed plus 5. Well, 4 times 2 is 8. 2 cubed is 8, so this is going to be 16 here. Then we add 5. So that's negative 8 plus 5 gives us negative 3. And the answer is C. There are a lot of C answers, it seems like.